Hi, everybody. Mr. Rubo here, and we are doing topic 1.6, polynomial functions and end behavior. End behavior, the end behavior of a function describes how a function behaves as it moves infinitely to the right and the left. So it doesn't care about the middle stuff. It's all about the ends of the graph. Okay. In other words, the end behavior is what happens to the values of f of x, or of the output values, as x increases or decreases without bound, which in other words means forever. Okay, as we get really, really big. Okay, so there's some notation we have to do here. So left end behavior, the way we write this is we write LIM, which stands for limit. And it's saying as x approaches, because we're talking left, it's the negative infinity of whatever the function is. Okay. And then right end behavior is almost identical, except it's to positive infinity. Okay. So the limit as x approaches negative infinity of f of x, limit as x approaches infinity of f of x. You could also say as the x values decrease without bound. Without bound means goes to negative. Decrease without bound is going to negative infinity. Increasing without bound is going to positive infinity. And then we say the y values of f of x, and then we would say it equals something. So let's go ahead and just talk about these graphs. So for A, left behavior verbally. So we're going to actually just write out what it's doing, and we're going to use our words. So if you look at this left end, so that's this side over here, we would say that as x decreases without bound, f of x increases without bound. Okay. So this is another way of saying, as we go to the left of this graph is going to positive infinity. Okay. The way we'd write this with our notation is we would write LIM as x approaches negative infinity of f of x equals, and it equals infinity because it's going straight up. Okay. So there that one is. Okay. Now we're going to switch it around, and now we're going to look at this right side. So let me do that real quick. Okay. And now we're going to do it verbally. So we would say as x increases without bound, because we are talking the right end behavior, we are going to say f of x, and this time it's going down, which means it's decreasing without bound. Okay, I don't want it to go into the next one, so there we go. All right, so now there that is. That's how we would say it verbally, or write it verbally, if you will. And to write it mathematically, we do the same thing, except this time we say as x approaches positive infinity of the function equals, and this again goes, it's decreasing without bound, which means it goes to negative infinity. Okay. The other graph, here we have the left side. So we're starting with the left side. It's going straight up, which now ends up meaning that we're going to write the same exact thing. So I'm actually going to cheat, and I'm going to copy and paste because I can do that on my computer. But there we go. So there's this answer. Okay. So we're going to say as x decreases without bound, because it's left end, f of x increases without bound. Okay. And the limit notation is the same as the one on the left. So as x approaches negative infinity of f of x, it goes to infinity. All right, now the right side behavior, well, this graph doesn't do the same thing on the right side. It goes up, so it's going to go to positive infinity, which here, as we type it, as x increases without bound, f of x also increases without bound. Okay. So there's that one, and this limit notation is going to be as the limit as x approaches infinity of f of x, because it is right end, it's going to equal infinity because it is going straight up. Okay. So yeah, there's our end behavior video. So thanks for watching and have a good day.